Dear students, welcome to Module 5 of Design of Machine Elements. Myself, Harikrishnan C, Assistant Professor, Mechanical Engineering Department, Rajagiri School of Engineering and Technology. In this particular module, we will study the various aspects of designing of belt drives and chain drives. In this session, we will discuss about the theoretical aspects of design of belt drives. We will discuss about advantages and disadvantages of belt drives, how power is transmitted through a belt drive, and which are the belt materials and its construction. And we will discuss about the length of belt and discuss about belt tensions in V belt and flat belt, and the belt creep and slip of the belt drive. Belts are used to transmit power between two shafts by means of friction. There are two types of drives, rigid and flexible. Belt, chain and rope drives are called flexible drives. Gear drives are called rigid or non-flexible drives. In gear drives, there is a direct contact between driving and driven shafts. In flexible drives, there is an intermediate link such as belt, rope or chain between the driving and driven shafts. When we come to the selection of drives, there we can select either flexible or rigid drives according to the requirements. If we are selecting the belt drives, there are certain advantages as well as disadvantages. When we are focusing about the advantages, flexible drives transmit power over a comparatively long distance due to an intermediate link between driving and driven shafts. It is smooth and silent. It can transmit only a definite load. And since the intermediate link is long and flexible, it absorbs shock loads and damps vibrations. And the design is simple. Flexible drives are cheap compared to gear drives. Their initial and maintenance costs are low. When we comes to the disadvantages, it occupies more space because the large dimensions, the bulky construction, it occupies more space. The velocities ratio is not constant because of belt slip. Here a chance of heavy loads on shafts and bearings. Low efficiency due to the loss of power, and the service life is short. In this figure, we can see a power transmission belt drive. This belt drive is called a serpentine belt. It is a single continuous belt used to drive multiple peripheral devices in an automotive engine, such as alternator, power steering pump, water pump, air conditioning compressor, air pump, etc. The belt may also be guided by an idler pulley. Here, the life of belt in an automobile engine, or it can be replaced between 40,000 and 70,000 miles. However, we have seen cases where the belt lasted over 100,000 miles. The desirable properties of belt materials are listed here. The belt material should have high coefficient of friction with the pulleys. The belt material should have high tensile strength to withstand belt tensions. The belt material should have high wear resistance, high flexibility and low rigidity in bending in order to avoid bending stress while passing over the pulley. The belt materials, when we are coming to the belt materials, belts are made of leather, canvas, rubber or rubberized fabric and synthetic materials. There are two types of flat belts, leather belt and fabric rubber belt. Leather belt is made of best quality leather obtained from either side of backbone of a steer. There are two varieties of leather, oak tanned and mineral or chrome tanned. The main advantages of leather belt is the high coefficient of friction and consequently high power transmitting capacity. Here there are two images. One is flat drive and one is the V drive. First consider the case of a flat drive. There is a specific term, ply of the belt. In order to make a practical thick belt, the layers of belt materials are cemented together, shown in the figure. These layers are called plies of the belt. Belt are specified according to the number of layers or plies, single ply, double ply or triple ply belts. Power rating of the belt is also specified per ply of the belt. High rating of the Dunlop high speed belt, the power rating of a Dunlop high speed belt is 0.0118 kilowatt per ply per mm width of the belt. Then consider the case of V belts. V belts are made of polyester fabric coats. Here there is an image shown here. You can see in the below figure the material that we are constructing in such a manner that there are three parts. The central load carrying coats, the central load carrying layers of polyester coats or polyester fabric which are located on the horizontal lines near the center of gravity of the belt cross section. The surrounding layer, here we can see the surrounding layer of rubber to transmit force from coats to sidewalls, and the outer polychloroprene impregnated elastic cover. This is the elastic cover. And here, considering the case of the fabric rubber belts, it is having high load carrying capacity, longer service life and high operating speeds. And coming to the disadvantages, they cannot operate on small diameter pulleys and they are subject to destruction in an environment of mineral oil, gasoline and alkalis. Flat belts are produced in the form of long bands and stored in the form of coils. The ends of these belts are joined by methods as illustrated here. There are mainly three methods: cemented joints, laser joints and joints with metal fasteners. When we come to the cemented joint, leather belts are cemented with a tapered lap joint of length 20 to 25 times the belt thickness. Multiple ply belts are cemented in the form of stepped joint. Cementing is widely used for rubber and leather belts. The strength of cemented joint is 80 to 85% of strength of the belt. Then laced joint. Lacing is done with catgut or with rawhide strips. Is shown here. The strength of laced joint is 50% of the strength of the belt. Third method is joints with metal fasteners. Shown figure, Metal fasteners require least time to make the joint. However, they are not suitable for high-speed operations. The strength of screwed or hinged joint is 25% of the strength of the belt. There are two types of belt construction, open and crossed. Here in this figure we have an open belt drive. Just to see the working of an open belt drive. Open belt drive is the belt drive in which the belt drive is proceeds from top of the one pulley to the top of the another without any crossing. See, here we can see that in this figure also, the top to top, and both the pulleys are rotating in the same direction. But in the crossed pulley, the top of the one pulley to the bottom of the another crosses over itself. In both cases, driving and driven shafts are parallel. In an open belt drive, both driving and driven shafts rotates in the same direction. Here we are going to find the total length of the belt. Here it is very easy to find total length by adding this length plus these two length and this length. By using simple geometric principles, we can find the length of the belt. This you have already studied in the first module, first semester of Basics of Mechanical Engineering. Here theta S and theta L are the wrap angle of smaller and larger pulley, and capital D is the diameter of the bigger pulley and small d is the diameter of the smaller pulley. And here the C value is the center distance in mm. All dimensions we are using in mm. Here this equation represents the total length of the belt. This is available in our data book, equation number 14.2b. And wrap angles also can be calculated using the fundamental geometric principles. Here it is pi minus capital D minus small d by c. Here it is pi plus capital D minus small d plus c. Considering the case of crossed belt drive, here the belt drive working like this from top to bottom. When we are considering the case of the rotation of belt cup pulleys, as it crosses, one rotates in anti-clockwise direction and one rotates in clockwise direction, and top to bottom connection is taking place. The belt has to bend in two different planes. Here in crossed belt drive, it rubs against itself while crossing. As these two factors, one is it rubs against itself while crossing, and it has to bend in two different planes. These two factors increase the wear and reduce the life of the belt. Here in open belt drives where the center distance is more, as the belt whips, that means it vibrates in direction perpendicular to the direction of motion. When the center distance is small, the belt slip increases. Both these factors limit the use of an open belt drive. Crossed belt drives do not have these limitations. Here the length of the belt can be calculated by simple geometric principles. You will obtain the equation like this. Here wrap angles of small pulley and big pulley are equal. It can be obtained by this equation. For doing the problems related to belt tensions of belt drive, flat as well as V belt, we have some fundamental relations. Just refer to the current slide. ratio of belt tensions. It's a universal used equation. T1 by T2 is equal to sigma 1 by sigma 2 is equal to e raised to mu theta. Sigma 1 comma sigma 2 is the unit tensions of belt on tight and slack sides respectively. And when we are considering the forces acting on the pulley, we have the centrifugal force equation is equal to T1 minus Tc divided by T2 minus Tc. The same is equal to sigma 1 minus sigma c by sigma 2 minus sigma c equal to the ratio of belt tensions raised to mu theta, where sigma c is the centrifugal coefficient for leather belts. Here we can see a relation between T1. T1 is the tensions of the belt in tight and slack sides T1 comma T2, and unit tensions. There are relations between tension and unit tension. One is the force and the other thing is the stress parameter. And when it comes to the centrifugal tension, Tc is equal to W dash V square by G, where W dash is equal to weight of the belt. Weight of the belt, Newton per meter or kilogram per meter length of the belt. It can also calculate as WBT by 10 raised to 6, where W is equal to weight density of the belt material into the area. Then the equation for coefficient of friction, it's also called the Barth formula, and equation is equal to mu is equal to 0.54 minus 0.712 divided by 2.542 plus V, where V is the velocity of belt in meter per second. When it comes to the V belt, we have the fundamental equations. Ratio of belt tensions is equal to T1 by T2 is equal to e raised to mu1 theta, where the same is equal to the ratio of unit tensions of belt on tight and slack side, sigma 1 and sigma 2, and centrifugal force is equal to T1 minus T2 Tc divided by T1 minus Tc divided by T2 minus Tc. The same is equal to the ratio of sigmas, and it is equal to e raised to mu1 theta. And when we considering the apparent coefficient of friction, the value of apparent coefficient of friction mu1, where we are using the equation mu1 for belt tensions, where we used where symbol mu, the same friction value for the flat belts, but here we are using the value mu1. Mu1 can be calculated using the equation mu1 is equal to mu by sine alpha by 2, where we can alpha is the groove angle of the pulley. It can be obtained from a table near to the equation. And here also we can use the coefficient of friction equation, the Barth formula that we discussed in the previous slide. There is a peculiar phenomenon in the belt drive which is called creep. Creep is a slight relative motion of the belt as it passes over the pulley, which is shown in figure. The exaggerated mechanics of creep. While moving from the tight to loose side over the pulley, the belt element is transferred from zone of higher tension to zone of lower tension. As the tension in the belt is reduced, the belt becomes shortened and creeps along the surface of the pulley. This causes a relative motion between the belt and the pulley surface. And what are the disadvantages? Creeps results in decrease in angular velocity of the driven pulley from that calculated by considering the ratio of diameters of pulleys. And the efficiency of the belt drive is reduced by 1 to 2% as the results of creep. Like creep, other unnecessary phenomenon is slip. In this video, it is explained clearly. Slip is caused by overloads, and in this case the belt slides over the entire arc of the contact on the pulley. Here there is a driving shaft and a driven shaft. As the driving shaft rotates, the pulley slips over the driven shaft, and hence there is a loss of power. In slip, there will be the causes of slips are low frictional resistance, low tension in the belt. And slip is the difference between speed of driver pulley and the belt, comma, belt and the driven pulley. The difference in speed.